name is Mohammed. I'm doing a presentation on the bridge design pattern. The intent of this pattern is to decouple an abstraction from its implementation so that two can vary independently, publish an interface in an inheritance hierarchy, and vary implementation in its own inheritance hierarchy. Beyond its encapsulation to installation. Motivation behind this pattern is that when abstraction can have one or several possible implementations, the usual way to accommodate them is to use inheritance. An abstract class defines the interface to the abstraction and concrete subclass implemented in different ways. But this approach isn't always flexible enough. Inheritance binds an information to the abstractions permanently, which makes it difficult to modify, extend, and reuse abstraction and implementation is independently. The participants in the bridge design patterns are abstractions, refined abstractions, implementer, and concrete implementer. And the abstraction is the core of the bridge design pattern and defines the crux, contains the reference to the implementer. Refined abstraction extends the abstraction, takes the finer detail one level below, hides the finer elements from the implementers, and you can have more than one refined abstraction. It defines the interface for the implementation class. This interface does not need to correspond directly to the abstraction interface and can be very different. Abstraction implementation provides an implementation in terms of operations provided by the implementer interface. The concrete implementation is the implements the above implementer by providing concrete implementation. And for this you can have multiple concrete implementations. Now let's look at a simple structure of the bridge design pattern. So right here we have the abstraction, which is composed of the implementer class. An abstraction can provide some methods, and also can have abstract methods that the defined abstraction implements. So here, the defined abstraction 1 and defined abstraction 2 implementing the operations method that is defined in the abstraction class. And over here, it's the same thing. The concrete implementer 1, concrete implementer 2 is implementing the implementation method, which is defined in the implementer class. Some advantages of the design pattern is bridge design pattern decouple an abstraction from its implementation so that two can vary independently. It is used mainly for implementing platform dependence feature. It adds one or more method level redirection to achieve the objective. We use design pattern to run the runtime binding of the implementation. We can also use these bridges to map orthogonal class hierarchies. Bridge is designed upfront to let abstraction and implementation vary independently. Some disadvantage of this pattern is that it increases complexity, and it also has double indirection, which can have slight impact on performance. The abstraction needs to pass the message along the implementer for the operation to get executed. Some node use of this class is like when you want to have one device that can configure to use multiple different devices. So an example would be a remote that control multiple devices differently. So say a TV company, a company can have two devices, like say a TV and then DVD, but they want to use one remote to control both devices. And then with bridge design pattern, they can configure the remote based on each device needs. So say the remote has only one button. So for TV, that button mutes the TV, and then so for DVD, that button pauses whatever is playing on the DVD. So let's look at an example that I came up with for this design pattern. Here's the problem that I came up with. Let's say you're trying to build a universal keyboard which can be configured to use on all the different kind of devices like a Windows computer or a Mac computer. So here's our computer, and computer has computer will be our implementer. So there's two concurrent implementer, which is Windows and the second one is Mac. And then the keyboard will be our abstraction, and then there were two refined abstraction, which is the Windows keyboard and then the Mac keyboard. And then so the abstract computer class is gonna hold all the similar methods that both these computers gonna have with the computer's gonna have, such as like this thing can hold type, and then and then these two classes will define the type of the computer. And then let's say if someone says it's can hold a method called button press, so whenever a button is passed through the function, it will print out, say press this button on this Windows computer, press this button on the Mac computer. And then the Windows and then the keyboard will hold the differentiating factor between the two keyboards. So let's say the differentiating factor between the two keyboards is the control key on the Windows and the command key on the Mac. So we can put a class called we can put a method in here called special key. So we can from the main we can call a function. We can call the special key function, and then it'll spit out let's say a special key control path pressed from Windows, and then special key command pressed from a Mac. Let's see the code for this program. So here's the UML diagram for the program. Here's our keyboard. Here's our abstraction class, which is the keyboard, and this is our implementer class, which is the computer. And then this is a composition relationship. So the implementer is composed into the keyboard abstraction keyboard class. So we're referencing the computer in here. And then it's gonna have two methods, a button press and a special key. And then the special key which is gonna be the differentiating factor, it's gonna be implemented in the refined instruction and then each refined instruction is gonna have its own constructor. And the button press will be defined in the class itself. Since it's an abstract class, we can define it in the class. And the concrete implementers, which is gonna implement the button pressed, and then button pressed, which is a void method that is defined in the implementer class, and then they're gonna have their own constructors as well. So here's the code for the program. So let's start with the implementer, which is the computer. It's gonna have a string of type, and then an abstract method of button press, and it's gonna take in a string of a button. And then so for these two items gonna be implemented by the concrete implementer. So let's look at the concrete implementers now. Let's look at the Windows. In the construction of the Windows class, it's gonna set the type. The type is gonna equal to Windows, and then whenever this function is called, it's gonna say pressed whatever the button value of the button is, and then on, and the type will be Windows computer. And it's going to be the same for Mac. So the constructor type is going to be set to Mac, and then it's going to print out the same thing as Windows, but we'll say Mac instead of Windows. So now let's look at our abstraction class, which is the keyboard. So like I said on the presentation, keyboard is gonna hold a reference to the device, which the device will be this device will be set in the construction the constructor of keyboard. So we're gonna so when we're when initiating the object in the main, we're gonna pass in the reference of a device through that constructor. So this device in the class will be equal to the device that is passed in. And then when on the button pressed, we're going to pass in a string, and then device, we're going to call the button pressed in the in one of the concrete implementers, and then it's going to pass in the button value from the main to that function. So let's look at the refined abstraction. So in the refined abstraction, it's gonna have a constructor. Constructor gonna get have a parameter of device, and as whatever device is passed in, it's gonna be set to the super, which is gonna call the superclass, and it's gonna pass in the device from Windows from this constructor. And then, like I said before, the special key function. Oh, I forgot to mention in the keyboard class, I have another abstract method, which is the special key method, and then the two refined abstractions gonna implement this method. So Windows keyboard gonna, as defined in the saying, that press the special key control on Windows, and then Mac is gonna do the same thing, but same like constructor and everything, and then it's gonna say command on Mac. So let's look at the main class. So here we are creating two classes called the keyboard, Windows keyboard, and then Mac keyboard, and we are calling the since this abstract class, we are initiating this by calling the Windows keyboard class, and we're passing in the one of the concrete implementer, which is Windows, and then doing the same for the Mac, and we're passing in the Mac. We're passing the Mac concrete implementer. And so now whenever we do Windows keyboard button pressed I, and then Mac keyboard button pressed I, and then we call the special key function Windows keyboard special key, Mac keyboard special key. It's gonna print out the following. So like here, this function pressed I on Windows computer, and then press I on Mac computer, and then Windows keyboard special key, it's gonna say press special key and control on Windows, and then Mac keyboard special key, it's gonna say press special key command on Mac. And yeah, I hope whoever watches this video understand what bridge pattern is, and yeah, this is the end. Thank you.